Welcome everybody. It's Ramachandra from CIVIL-MECH-MATHS concepts. CIVIL-MECH-MATHS concepts. Until structural analysis lecture number 10, we have taken up moment of inertia of various shapes for the last 4 to 5 lectures. Previous to that, we have discussed about the types of forces, types of stresses in the members, tension and compression, how to identify the forces in the members, and how to calculate the member stresses in a truss beam and also in the beams, regular beams, in trusses, pin jointed trusses members, and also in the regular beams. Now, we have even discussed about the bending stress, shear stress, and combined bending and torsion stresses and their importance, and how to calculate the maximum bending stress from section modulus. Z is equal to section modulus, that is equal to moment of inertia by y. Y is the fiber distance under consideration from center of gravity, at which point we require the section modulus. So that once section modulus is known, then sigma is equal to m by section modulus. This is the equation we have derived in the last class. Now from this class onwards, we start using this sigma and find out equation and find out the value of the stresses, bending stresses. And because of these bending stresses, there will be vibration in the beam. And the equations for the vibrations are to be derived. That will be done in the following classes. Today, I have taken up a very big numerical, very important numerical. It covers almost all the concepts related to the bending moment and vibration of the beams. Very, very important. Even vibration of the beams is covered in this particular lecture, in this particular problem. And for solving the total problem, it may take 2-3 lectures. In the first lecture, I will be going for solving the bending stress. And here in this problem, I have used sine curve beam, and beam cross section is sine curve. But it's a regular beam. This is the big problem which I have taken care of, which I have considered for solving in the next 2-3 classes. It's a cantilever beam I have taken. And a cantilever beam is carrying a UDL. And the maximum bending moment and the maximum stress is calculated and that stress is used for finding the cantilever beam load acceptability, natural frequency of the cantilever beam, maximum strain gauge reading, and the maximum deflection. Like this, I have taken a beam, initially one beam. I have calculated for that particular beam the bending stresses. These bending stresses will be limiting stresses for me. Following beam, and in the next cantilever beam, we are supposed to calculate the what is the load, point load that it can carry, and second, what is the natural frequency with which the cantilever beam vibrates, and what is the maximum deflection. These calculations are to be done. It's a very, very important problem. It is particularly made by me for the benefit of all your GATE and SSC JEE aspirants, so that please take advantage of this particular problem in understanding the concepts from this problem, so that the same concepts can be applied everywhere, anywhere you want, as per the questions given in the examination. Now, it's Ramchandra again from CIVIL-MECH-MATHS concepts, and 56 videos are released from this channel. Please view, review and comment on them. All the videos are of very, very important concepts and very useful for you in long run in your professional life, and also for writing the GATE examination and SSC JEE examination. And also they will be of much use to you, and don't neglect any video. Please see them. If you did not understand anything, please write to me at the handle, so that I will reply to you. Please comment on them for improvement. Please subscribe to my channel. With dedication I am doing all this. Please understand and take advantage of the concepts being discussed in each and every class. We will go to the problem now. The problem is based on combined bending and torsion in the beam. Here, even though the heading is combined bending and torsion, in this particular problem I didn't discuss about the torsionate, and hence I am not included. In the particular problem, a factory is there in which a beam is there. It is in the shape of a sine wave with a cross section in the shape of a sine wave. Cross section is sine wave cross section, and the limiting stress in the premises of the factory, the limiting stress of any other equipment in the premises of the factory is the maximum stress in the sine wave, maximum applied stress in the sine wave beam. And sine wave beam has a maximum height of 300 mm, breadth of 900 mm and 2 meters length, carrying a UDL of 1 kN per meter. The sine shaped curved beam is placed such that its breadth is horizontal. The UDL is along the length. It is like this. It is a sine shaped, it is a cross section. This is cross section. this is the cross section and this is the length 2 meter and UDL is there on it, and it's not given here whether it is a cantilever or a simply supported. For the sake of brevity, we will say it is a simply supported instead of a cantilever. And this is W, UDL is 1 kilonewton per meter. Previously I told cantilever, but let us take a better beam. It's not mentioned cantilever or simply supported. Let us assume it is SSL, simply supported beam, SSB. Now, the cross section when it comes into play, when we have to find out the bending stresses, at that time cross section comes into play. Cross section will not have any bearing on the calculation of bending moment. Irrespective of the cross section, the loading and length of the beam decides about the bending moment. Stresses will be calculated on the basis of your I and Y. I and Y can be calculated from your cross sections. Now, this is the maximum height for a cantilever beam, and breadth, this is the total breadth B of the cantilever beam, 2B, that is equal to 900 mm. Height is equal to 300 mm. UDL is there. For this, we have to find out the maximum stress in sine wave shape beam. This is the limiting stress in the premises. This means sigma maximum of sine wave beam. This is the limiting stress for the second part of the problem. In the second part, we have another beam in the factory with a sigma maximum is defined in the first part of the problem from the simply supported beam. Why I have taken simply supported? So that you can have a feel of solving with different types of beams in the same problem. First part is simply supported, second part is cantilever. If you take same thing in both the parts, it's not be a value addition. I want to give value addition to your time and also your efforts in understanding me. Now, the sine wave cross section is defined, length of the beam is defined, UDL is given. From that we can know the bending moment maximum, type of the supports are given. Once you know the bending maximum bending moment, then from this we can find out the, by using the beam theory, sigma maximum is equal to Bm maximum by Z maximum. Z is nothing but I by Y. Let's go for this. Let us solve the first part in this lecture, and for the second part it has 4 subparts, very lengthy. Why I have given this much lengthy problem is that almost everything about the bending stresses is covered in this problem. If you can understand and solve this problem, you will be almost ready with answering some good questions regarding these bending stresses in a beam. Now in the second part, the cantilever circular shape beam. Cantilever is circular shaped. It is a 1 meter length and 50 mm diameter with a load X applied. on it at the free end. Cantilever beam is like this. This is 50 mm dia, this is 1 meter length, and a load X is applied at the end. With the limiting stress whatever we have calculated for sine wave beam, by using that find out the X. What is the maximum load that can be applied on the free end of the cantilever beam? We have to find X in kilonewtons. Natural frequency of the cantilever beam. By applying the forces, what happens? Cantilever beam vibrates. This natural frequency. This we have not done, but still I have given in the problem, so that along with the problem we learn how to calculate the natural frequency of a beam. Then maximum strain gauge. Strain gauges are fixed for finding the strains in the beam whenever loads are applied. Then what is the strain gauge reading is nothing but maximum strain. Compressive strain will be like this. Here it is compressive, here it is tensile. If the beam is bent like this, then compressive strain, it is the compressive strain maximum. Here tensile strain maximum. We have to find out whether tensile strain is more or compressive strain is more. What is the maximum strain? And there becomes the strain gauge reading in microstrains. Strain gauges are always used to read in microstrains. Please remember this. It may come in your objective type questions. 10 to the power of minus 6 is equal to micro. Find the maximum deflection. Maximum deflection will be at the free end. It will happen at free end. I think to understand the problem itself, it took much of the time, and first we will take up the part 1. In the part 1, to find out the sigma maximum, we have to find out the bending moment maximum and the maximum section modulus. To find the section modulus, I of the sine wave, the moment of inertia of the sine wave is already discussed in my previous lecture. Please refer to my lecture on sine wave, and please refer to my lecture on sine wave, moment of inertia of sine wave. And if you want, you see it for 2 or 3 times, understand that I clearly explained how to calculate the moment of inertia for a sine wave in structural analysis lecture some 13 days back from now. And now we will start. We will start solving the problem. We will start solving the problem. What it was told? Part 1. Let us take part 1. Let us take part 1. The pen is very thick. Let me reduce the pen thickness. Part 1. In part 1, let us take the beam as it is. Let us not take the, for calculation of bending moments, we need not worry about the cross section. This is the beam. This is A, this is point B. Length is how much? It is 2 meters. And what is the SFD? RA and RB? This is 1 kilonewton per meter. That is equal to W. Kilonewton per meter. UDL. It is uniformly distributed load. UDL means. Now, from symmetry, we have already calculated in the previous classes. From symmetry, reaction at RA is equal to RB, reaction at B. That implies WL by 2. RA is equal to WL by 2. W is 1, L is 2 divided by 2. That means 1 kilonewton. This load is 1 kilonewton. This load is 1. This reaction is 1 kilonewton. This is the beam. Now, what is the shape of the bending moment? Diagram. BMD I have also already discussed about the simply supported UDL, because it is the usually common beam which appears in regular engineering applications. It's positive. Both the sides upwards is positive. This is positive bending moment, so that it will be like this. This will be the bending moment. At center, maximum bending moment will be there. These are all things I have discussed in my previous classes. Please refer to them. Maximum, this is A, this is B. At center C, maximum bending moment. Therefore, M maximum is equal to WL square by 8. Please remember this formula. For a simply supported beam, UDL in this form, this maximum bending moment is equal to WL square by 8. I will discuss about the bending moment values when I calculate the bending moments, and definitely I will give all the values for different types of loadings. Now, bending moment is there. Then we have to calculate what we require from the beam theory. From beam theory, sigma is equal to bending stress is equal to M by I by Y. Now to calculate I by Y, Y max we can say. To calculate I by Y and I, we have already calculated M. M is equal to, what is the value of M? M max is equal to WL square by 8. That is equal to 1 into, what is L square? 2 square by 8. 4 by 8. That is equal to 0.5 kilonewton meter. This is the value of the bending moment. I think you are able to understand this. Maximum bending moment is equal to WL square by 8. Now, for a sine shape, for a sine wave shape, now the value of M is calculated or obtained, I value is required and Y max is required. Now one by one we will go. I is required at center of gravity. What is the sine wave form? I have already shown in the previous slide. Sine wave, one sine wave, let us say like this. It is the sine wave, because sine wave can be, let us take only one part, and this total is the breadth, let us say it is 2b, that is equal to 900 mm. Because of the uniformity, at the center it will have the highest height. This is h. What is the value of height? In the problem, the maximum height is 300 mm. And breadth, total breadth, 2b, this is the b. Please refer to my previous lectures to understand better. This is b. What is the value of b? 2b is equal to 900 mm, implies b is equal to 450 mm. 2b is the total breadth. Now, for this combination of the load, and let us say it is the center of gravity CG. This is Y bar, because it is told the beam is placed its breadth as horizontal breadth. This is the base. Please try to understand. Each and every sentence is important in the problem. This is the base on which the beam is resting. With respect to base x-axis axis, the height of the y coordinate of the center of gravity is y bar. That I have repeatedly told in the last 5 to 6 lectures. Please refer to my last 5-6 lectures for this. Now, what is the value of yc? That is equal to y bar. What is that value? Pi h by 8. This is the value which we have derived in our previous lecture on sine wave form shaped beams. Please refer to that lecture and you can understand how y bar or yc has come. Pi into h is how much? 300 by 8. This is y bar. Now, calculate y bar. Pi into what is h? 300 divided by 8. That is 117.8. Let us say for brevity 118. Let us not worry about the digits because it is already, measurement is already in mm. 118 mm. Y bar is 118 mm. Where is the maximum fiber? Maximum fiber is at the highest top. Maximum fiber. Then the distance between the maximum fiber and the y bar is y is equal to (300 minus y bar). For understanding this, you please refer to my previous lectures. This is the point where vulnerability is more at the maximum fiber. Vulnerability is the highest. That is 300 minus y bar. 300 minus y bar means 300 minus 118, that is equal to 182 mm. Y is equal to 300 minus y bar, that is equal to 300 minus 118, that is equal to 182 mm. Now you got the value of y max. Now what are the values we have calculated as of now? Bending moment maximum is equal to 0.5 kilonewton meter, and y max is equal to h minus y bar, that is distance from the last fiber to the center of gravity, that is equal to 118 mm, that is equal to 118 into 10 to the power of minus 3 meter. For that reason only, because the distances of the cross sections are very, very less when compared with the length, these strains are calculated in microstrains. Strain gauges are made with microstrains. They are called as microstrain gauges. Now, just for your understanding, I will again give the shape. Always go with the geometry, never go with theory. Now, this is the CG at a height of 118 mm. What is our theory? At neutral axis. What is the beam theory? Beam bends like this. At neutral axis, along the neutral axis, the length does not change, the breadth does not change. That means strain is equal to 0. And because loading is like this, and in this particular example, movement is positive this way, this is minus, this is plus. Then can you try to draw the strain diagram? This is strain will be negative here, that means negative. Center of gravity is here. At center of gravity the strain is 0. This is minus compressive strains, this is plus tensile strain. Now you see which is the maximum? Compressive strain is the maximum. In this, compressive strain is greater than tensile strain. Please try to understand this concept. Once you get the value center of gravity, because this height is 182 mm and this height is 118 mm. Hence, the tensile strain is less in this example, compressive strain is more, and compressive strain is greater than tensile strain. And hence the maximum strain, bending strain will be, maximum bending strain will be, in this example, please clarify your doubts. In this example, maximum strain will be due to compression. Hence, maximum stress will be due to compression. Compressive strain and compressive stresses are maximum. This is from the diagram itself. Now I didn't get the quantity. I have got the quality of the problem. Now I solved almost 90% of the problem. Now I have to get the quantity. Now, for the sine wave, what is the ICG? ICG for sine wave is equal to 8 by 9 pi minus pi by 16 into BH cube. That is equal to 0.0866 BH cube. For this, you please refer to my earlier video in which I have derived this expression. I have solved the moment of inertia and center of gravity of the very important. My last 6 lectures are very important for understanding the structural analysis. Please go back to them. Now ICG is there with you. Ymax is there with you. It is H minus, sorry, it is not 118, it will be Ymax is equal to H minus 300 minus 118. That is equal to 182 mm. Y is 182. This is Y. You just see, center of gravity is 118. Okay. Now, Ymax is 118 center of gravity and Ymax is 182 mm. Now, please calculate sigma max. Sigma max is equal to M max divided by I by Y max. What is I by Y max? I by Y max is equal to Z max. Therefore, but here I have to calculate I. What is I? I is equal to 0.0866 BH cube. Everything we have to convert into SI units. Please be careful with the units. 0.0866 into what is the breadth? Breadth is 450 mm. 450, B is 450 into 10 to the power of minus 3. For this, because this total is 2B, when we have considered the beam, please refer to my earlier lecture. When 2B is equal to 900, then what is B in the formula? The value of B in formula is 450. Mm is 10 to the power of minus 3 meters. And H cube is, H is 300. This total H is 300 mm. 300 into 10 to the power of minus 3 cube. Now try to find out this value. This ICG of the sine wave is equal to 0.0866 into 450 into 10 to the power of minus 3 into 300 into 300 into 300 into 10 to the power of minus 3 cube is equal to 10 to the power of minus 9. That is 0010.00105219 meters to the power of 4. If you calculate in mm's, it will be a very big value. When you calculate in meters, please be very careful with the units. This is the moment of inertia of the cross section of the sine wave. Now, y max, this is equal to, I can say, 0.182 meters. Therefore, Z max is equal to ICG by Y max, that is equal to 0.00105219 whole divided by, what is Y max? 0.182 divided by 0.182. This is 0.0058. What are the units of Z max? Cubic meter. Z max units are cubic meter. I units are m to the power of 4. Now, what will be the sigma max? Bending moment is kilonewton per meter. Kilonewton is not the SI unit. Newton is the SI unit. When you convert it, what happens? Here now we will write the values. What is the value of m max is equal to what we have calculated previously? 0.5 kilonewton meter. Let us convert into SI unit. 0.5 kilonewton meter. That is equal to 0.5 into 1000 Newton meter. 0.5 into 1000 is equal to 500 Newton meter. And what is the Z max? That is section modulus, which denotes the strength. Section modulus of which is related to strength. 0.0058 cubic meter. 0.0058 cubic meter. Now, what will be the sigma stress? Sigma maximum is equal to m maximum divided by Z maximum due to bending. We are only till now talking about bending stresses only. Sigma denotes the bending stress. This is equal to maximum applied bending stress then sigma max is equal to m max is 500 Newton meter divided by Z max is 0.0058 cubic meter, that is equal to 500 divided by 0.0058, that is equal to 86207. 86207 Newton per square meter, that is equal to, when you convert it into kilonewtons, that is the practical unit, 86.207 kilonewtons per square meter. This is the value of the bending moment maximum applied or bending stress. That is the limiting stress as per the problem given. Therefore, limiting stress is equal to, for the equipment is 86.207 kilonewton per square meter. This is the final answer for the part 1, and with this value we have to find out stress has come, stress is known. Now we have to find out the load. That is that can be applied on the cantilever beam. That we will do it in the next class, next lecture. With this, today I want to conclude this lecture. And this lecture, if you feel it is useful to you, added some value addition to your knowledge, please subscribe to my channel. Encourage me by subscribing to my channel. Subscribe to CIVIL-MECH-MATHS concepts, so that I will bring this type of brainstorming questions to you and clarify the concepts step by step by solving the problems also, so that you will be benefited. Best of luck to everybody. Please subscribe to my channel. Please view all my videos, and links are given in the description of the video. At the bottom of the description, you please refer to those links and wait for my next lecture. And in that lecture, I will be solving the part 2. Part 2 may take a couple of days, couple of lectures, because it has got 4 subparts, in which I have to discuss about the deflection, I have to discuss about the vibrations, I have to discuss about natural frequency, strain gauge readings, and the pointed load value. These things, these will take one by one, we will take up, and once we solve all these problems of the part 2, you will have sufficient knowledge and you will appreciate the value addition to your knowledge regarding bending stresses in the beams. Best of luck to everybody. Thank you for listening to me. It's Ramchandra from CIVIL-MECH-MATHS Concepts. Thank you for listening to me. Thank you for viewing my lecture. Best of luck. Please